Of the chain rule. Sometimes the chain rule needs to be used more than once to find a derivative. So let's look at a couple examples of those. Like this one here, I have the cube root, and inside the cube root is a sine function, and inside the sine function is x squared. So it's a composite function done twice. So this is something we have to look at a little bit closer. So in the end, keep in mind the main guy is that cube root. So we start from the very inner part. Remember I said that we have the function of the cube root, inside is the sine value, inside sine is x squared. So u is going to be x squared. U prime, 2x. Then we're going to use v for the whole thing. But now keep in mind what we have now is a cube root of sine of u. So v is going to be sine of u, and v prime, derivative sine, cosine. And then now we have the cube root of v. And you can rewrite that if you must, v to the 1/3 power. So s of v is going to be v to the 1/3 power. So s prime at v is going to be 1/3 v to the negative 2/3. I was going to write 1/3, but it's negative 2/3. And our derivative, y prime, is still going to be all of the derivatives. U prime times v prime times s prime at v. So y prime equals 2x times cosine of u times 1/3 v to the negative 2/3 power. Okay, now besides cleaning this up, we have to undo our substitutions. So anyways, this had only x in it, so in the end we can only have x's here. So we have to plug in what u is and what v is. So y prime equals 2x cosine of u, which is x squared, times 1/3 v. V is sine of u, but u is x squared. And that guy is to the negative 2/3 power. Okay, let's make sure we got everything. 2x cosine of u. Cosine of u and u is x squared. Okay, 1/3 v. V is sine of u and u is x squared. So sine of x squared to the negative 2/3 power. Now we all know that this is an appropriate derivative, but let's clean it up. If we can clean it up, let's clean it up. So this is y prime equals 2/3x cosine of x squared, and this is in the denominator, so this is the cube root of sine of x squared, that whole thing there, squared, or some like to just leave it as the rational exponent. And no, we cannot do anything with that because cosines, their angles are the same, but this guy is under a radical. The sine value is under a radical, so you can't touch it. So either or, but I can also go back to this one is acceptable, this one is not, because you have u's and v's and everything else. You have to undo your substitutions. Okay, let's try another one. Tangent 5 minus sine of 2t. So again, we have tangent is our main function. Inside of it is a 5 minus sine of 2t, and inside of this guy is the 2t. So whatever's on the outside is going to be your main function. So if I let So this is what I call that side work. I know I wrote it on the last one, but didn't say what it was. It's just work that we need to do to get our answer, but we don't want it in the flow of our work. So U is going to be the innermost, which is 2t. So U prime is 2. V is going to be what's inside the parentheses, because this is our main guy, so he's going to be the last one to touch. 5 minus sine of 2u. Actually, we don't have to put in 2u, sorry, because we took out the 2t and replaced it with u, so it's going to be u. So v prime, derivative sine is cosine, so negative cosine at u. And then we have y, or you can write y or s of u, or in this case s of v, is tangent of v. So s prime at v is going to be secant squared of v. And our derivative is going to be u prime, v prime, s prime at v. So y prime equals 2 times negative cosine of u times secant squared of v. Now we just have to undo all of our substitutions. I'll put these two together so I get negative 2 cosine of u, and u is 2t, times secant squared of v. The v is the 5 minus tangent, 5 minus sine of u, but u is 2t. There is your derivative. Not pretty derivatives and not nice to play with either. Sometimes they are. Sometimes they are not nice to play with. Okay, one more. Why don't you pause it and see if you can come up with the answer before I give it to you. See how you do. So, okay, so let's see how you did. So you would let u equal the most inner part, which is 2x. So u prime would be 2. V is everything in the parentheses, so 1 plus cosine of u. So v prime is negative sine of u. And then s of v is just going to be v squared. So s prime at v is 2v. And then your derivative y prime is going to be u prime times v prime times s prime at v. Bunch of different derivatives put together. So y prime equals u prime is 2, v prime is negative sine of u, but u is 2x, times s prime at v, so times 2v. Oh, but we need, okay. I did the substitution here and not here. Okay, so y double prime equals, I'm going to go ahead and do the 2 and the negative and the 2, so negative 4 sine of 2x times my v, and v is 1 plus cosine of u, and u is 2x. And there's our derivative. Do not bother going through a lot more to try and clean it up a little more. It's not going to get you anywhere. So life is good. There it is. How did you do? Did you try it? Did you pause it and try it? Okay, it's just a reminder of making sure you know what's inside the function and being able to work with it. Okay, well that is the end of day 2, another little 10-minute video. So have it try on that, try some of the worksheets, and come in with questions tomorrow. Good luck.